Greetings, everyone. Today we're going to have a discussion about Pushdown Automata, or PDA, for module number 8. Submodule number 1 is all about PDA construction and parsing. Our objectives are as follows. Okay, at the end of the module, the learner you should be able to construct PDA for different languages and construct PDA from a given CFG. We might not be able to construct simple parser as part of the lesson for today, okay, but we will have it on the second meeting. Let's start with the pushdown automata, the core topic of today's meeting. Pushdown automata is a way to implement a CFG in the same way we design DFA for a regular grammar. A DFA can remember a finite amount of information, but a PDA can remember an infinite amount of information. A pushdown automata is simply an NFA augmented with external stack memory. The addition of stack is used to provide a last in first out memory management capability to pushdown automata. Pushdown automata can store an unbounded amount of information on the stack. It can access a limited amount of information on the stack. A pushdown automata can push an element onto the top of the stack and then pop off an element from the top of the stack. To read an element into the stack, the top elements must be popped off and are lost. A PDA is more powerful than an FA or finite automata. Any language that which can be acceptable by an FA can also be acceptable by a PDA. PDA or pushdown automata also accepts a class of language which even cannot be accepted by an FA or finite automata. Thus, PDA is much more superior to FA. A pushdown automata is a way to implement a context-free grammar in a similar way we design DFA for regular grammar. And DFA can remember a finite amount of information, but PDA can remember an infinite amount of information. So basically, a pushdown automaton is a finite state machine plus a stack. A pushdown automaton has three components. Keep in mind that they are input tape, a control unit, and a stack with infinite size. The stack head scans the top symbol of the stack. A stack, as we know from data structures, does two operations. Okay. Popularly, they are push and pop. Push, push means a new symbol is added at the top, while pop is the top symbol that is read and removed. Okay. A PDA may or may not read an input symbol, but it has to read the top of the stack every transition. Okay. Here we have an input tape. Okay. Uh, the finite control unit and the stack. Okay. The input tape is divided into several cells or symbols. Okay. Also, the input head is a read only and may only move from left to right one symbol at a time. Okay, so which then takes an input and pass it on to the finite control for processing. The finite control has some pointer which points to the current symbol which is to be read. Next, we have the stack that has push and pop operation. The stack is a structure in which we can push and remove the items from one end only. It has an infinite size. Okay. In PDA, the stack is used to store the items temporarily. And then finally, okay, the output is to decide whether, okay, to accept or reject a language. Next, definition of PDA. Okay, a PDA is a system which is mathematically defined as follows. So PDA is equivalent to Q or finite set of states. Okay, we also have the sigma symbol, which represents the alphabet or non-empty finite set of input symbols. Okay, we also have the S. Okay, S symbol that represents the stock symbol. A stock symbol that which can be pushed and popped from the stock. And our Z, okay, is a start symbol which is in your stock. Okay, that's why it represented by this symbol. Okay, and we also have the familiar transition symbol or transition function. Okay, which is used for mapping, which is used for moving from current state to another state. It's a mapping function in that case. And F, letter F, is a set of final or accepting states. Okay, that F symbol states must be one of the finite states represented by your letter Q. Moving on, we have this graphical representation. The following diagram shows a transition in a PDA from state Q sub 0 to state Q sub 1, labeled as A, B, and C. Okay, so this means that as at state 0, Q0, if we encounter an input string of A and the top of the symbol of the stack is B, then we pop B, then push C on top of the stack. Only then we can move to the Q1 state, which is actually represented by the description below. Next, here are some other terminologies related to PDA. Okay, so we have instantaneous description. The ID or instantaneous description of a PDA is represented by a triplet Q, W, S. Okay, where Q is the state, W is unconsumed input, and S is the stack contents. Turnstile notation. Okay, the turnstile notation is used for connecting pairs of ID that represents one or many moves of a PDA. The process of transition is denoted by turnstile symbol here. Okay. Consider a PDA of this tuple. A transition can be mathematically represented by the following turnstile notation. Here, as you can see on our screen, we have P, AW, and we have beta, and a turnstile symbol in between them, and another triplet. We have Q, W, and AB. So what does this mean? Okay, this implies that while taking a transition from P to state Q, from state P to state Q, the input symbol is A, okay, which is consumed, and the top of the stack T is to be replaced by a new string A, this one. Note, if we want 0 or more moves of a PDA, we have to use the symbol of this turnstile symbol with a star symbol or a clean, okay, for it to happen. Next, there are two types of PDA transition. You have to keep in mind, okay, first is having this transition symbol with our triplets Q, A, and Z. And this allows us to transition to another state by having the states P1, P2, and so on and so forth. And we have the Y1, okay, to represent our push. item, okay, or pushed symbol. Okay, y1, y sub 2, y sub 3, and so on and so forth. So we do first, the current state is Q. Let's point ourselves to this Q. Okay, next is the current input symbol is A. So we represent it with this letter A. Next, moving on. Okay, the symbol currently on top of the stack is a Z. So again, we are referring to this letter Z. Now move to the state P sub I from Q. Again, the P sub I refers to whichever currently you are pointing at. If you've gone to P1, you might be doing pointing to P2 and so on and so forth. Since currently we are starting this transition, therefore we should be able to point that we are referring from that P sub 1 or P sub I as your P sub 1. Okay, so we move from state P sub I from Q. Starting from Q, we go to P sub 1 in this case. Now, it is said here that we have to replace a Z with the Y sub I, which represents the symbol that you are about to push onto the stack. So here, we write the Y sub 1 or y sub I. Okay, for now, it's y sub 1 because we are just following whatever is being given here as our representation of the symbol. Okay, so the same can be said on to the other states if you have to move to P2, P3, and so on and so forth. We move to the input head to the next input symbol. Okay, so that is the first type of transition. Okay. Next, we will have the similar transition, but then again, but with a different input. This time, we have a triplet with Q and a null or epsilon, okay, and a zeta, okay. We still have our P1, Y1, and so on and so forth here. First, our current state is at Q state. We're going to move to P1. We have to follow this step. The current input symbol is not considered. Why? Because we are having an epsilon or a null as our input. The current symbol, okay, symbol currently on top of the stack is a Z. So this time we have a Z here. Okay. Move to the state P sub I from Q. So we have Q. Currently we are referring to P sub 1 right now. Okay. Next, replace the Z, which is our on our stock is a Z here. We are referring to this Z to be replaced by a Y sub I. In this case, we are referring to Y1. So again, if you're going to write it in this way, you have to make sure they are separated by a slash. Okay. Next, no input symbol is red. Why? Because we are referring to a null input. Next. So those are the two types. Okay. Moving on, we have the transition function. Okay. The transition function takes an argument at triple parameter. We have Q, A, and X, where Q is a state in our Q, which is, remember, the Q are finite set of states, right? And then A is either an input symbol in the sigma or the alphabet, or A is equals to a null. X is a stack symbol that is a member of S, our stack. Next, the output of the transition function is finite set of pairs P and Y. So we have ordered pairs here. So we have P is the new state where Y refers to a string of stack symbols that replace X at the top of the stack. Okay. So let's say, for example, if Y is equals to epsilon or null, then the stack is popped. If Y is equals to X, then the stock is unchanged. Next, if y is equals to y z, then x is replaced by a z and y is pushed onto the stock. Let's have this an example to really understand what I have said there. Okay, so here we have a transition, okay, in this visual transition of Q1 to Q2, which is represented by these two circles below. In order for us to move on to the other state, okay, here we have an input symbol of A. We'll have to write it here, an input, and then here's the thing that we have onto the stock, letter B. This is the thing that we are after, which is to be removed from the stock. Okay, and that W with a slash, okay, represents the symbol that we're going to push onto our stock after removing the B onto the stock. Okay, only then we can say that a Q1 can transition to a Q2. Next, moving on, pushdown automata is a non-deterministic. It is non-deterministic because it has multiple transition on same pop or input allowed. And it is non-deterministic because transition may but do not have to push or pop. Next, so how are we going to know a PDA or pushdown automata will accept a string? Okay, the input string is accepted if the ending state is a final state and the stack is empty. Let's have this as an example. Okay, let's take this example of another pushdown automata. This time we have a language of 0 raised to the n, 1 raised to the n, whereas n should be greater than or equals to 0, which means that we are referring to any number that are greater than 0. So it could be 1, 2, 3, 4, 5, so on and so forth. So again, if we have a value of 1, then definitely uh, that dictates how many times do we need to repeat these zeros and one. If we got two, then two times are required for these numbers. So they go in the same uh, numbers, okay, as their power. So they are their power. So let's have this transition diagram that we have on the top left. Okay, so here in this example, the number 0 and 1 have to be the same. Okay, so initially we put a symbol, definitely a special symbol this time, dollar into the empty stock. This is what I'm referring to, the one here. Okay, this line. Then at Q2, we encounter an input of 0. This is our input, that's 0. And the top is null. Okay. We push 0 onto the stock. And with that, this may iterate. And if we encounter 1, okay, this is now we are referring to, and the top is 0, we will pop this 0. Okay. We pop this 0 simply because we are pushing nothing onto it. Then at state Q3, this is what I'm referring to. If we encounter an input 1, this is the input, and the top is a 0, okay, we pop this 0 onto our stock. There's nothing to be pushed since it's an epsilon. This may also iterate, okay, we'll repeat. It will be a 1 and a 1 and a 1 and a 1 simply because it was being written here. Okay. Again, these are acceptable language. Okay. So if we have a 1, it might be repeated as another 1. Okay. If it's a 0 and another 0 again, we may encounter a repeated 0. That's why I say I am having those mentions, okay, in this lesson. So again, this may iterate, okay, for both zeros and one. Okay, and if we encounter one, okay, the top is 0, we pop the top element. Okay. Now, if the special symbol, this is what I'm referring now, okay, is encountered at the top of the stock, then it is popped out. And finally, it goes to the Q4 as its final state or accepting state. Next, moving on, let's have another example. Here, construct a PDA that accepts language, okay, of W raised to the R, or the strings raised to the R, where the string is equivalent to A or B star. Okay, which means that either A or B will be selected and then they will be repeated or not be repeated. Okay, that's what it says here. Remember, that's how a star or clean works, okay, for a certain string. So initially we put a special symbol again. This is our uh, $sign to initiate things, okay, for our empty stock. And at the state of Q2, let's take a look at this Q2. The string is being read. Okay, we have A as an input, and if our uh, stock is empty, then we push letter A. Or if we encountered a B and our stock is empty, then we push letter B onto our stock. Okay. Now, before we move on to the Q3, we also have this encounter. Okay. If we have encountered a null set or an epsilon, okay, and our stack is still empty, then we're pushing nothing, okay, or an empty string, a null rather. Next, moving on, we have the Q3. Each A or B is popped when it matches the input. Regarding with this, okay, if we have an input of A and our stock has a top of A, then we're not pushing something, okay? Because it's just a repetition. If any other input is given in the PDA, it will go to the dead state. Hence, the reason why we are just repeating everything here, okay? When we reach the special symbol, we go to the accepting state. We are ready to reach the Q4. That is again if we encounter a special symbol. Moving on, let's have this another example of our machine that has Q0, Q1, Q3, Q2 to Q3 as our states. Okay, and we have an input of A, B, C. Next, we have stock of A. We have here the transition symbol. We have this initial state and the final states Q2 and Q3. Here are our transitions. Okay, derived from our transition function. Okay, we can move from Q0 to Q1, from Q1 to itself, and a Q1 going to Q2, and an instruction from Q2 to itself, Q2 going to Q3, and a Q3 going to itself. Okay, so those are the transitions that we need to follow. Okay, but then again, just try to remember how we can understand these transitions. Okay, so here it can be gleaned onto the right side. Okay, we have the transition function that if this is the first parameter, we will think of it as the initial state, and the second parameter, okay, refers to your input symbol, and then this third parameter is the one that you will pop from the stack. And here we have another in the parameter on the right hand side of the this visualization. We have Q sub 1. This refers to be your next state. If you go, this will be your initial, and this is your next state. Okay. Then the last in the parameter is the symbol that you wish to push onto the stack. Okay, in this state, in this example, they are null or nothing to be pushed. Okay, and Next, moving on, let's take them one by one. Okay. So how are we going to draw it, okay, or illustrate it as a transition diagram? Okay. So let's go through them one by one using this slide. Okay. So if we were told to have Q sub 0 be as input and our stack is the top of the stack is nothing or empty, and that will lead us to connect to Q sub 1. Okay. We have here, we have to push nothing onto the stack. So by writing it down, we have the Q sub 0. Okay, let's draw a circle for Q sub 1 as well. We're going to bring down these symbols, B and this symbol. Okay, so therefore, we were left with only with B and an epsilon or a null, and then another null. Okay. Next, if following the second transition, okay, we have Q sub 1 to itself transition B, empty, and an A. So we're going to write these three symbols, okay, on top of it, okay, from the line. Doing so, we are now going to have the third one, okay. We have a transition from Q1 to Q2, which leads us to have these three symbols again. This time we have an input of A. This is that A, and this time the top to be popped is that big, capital letter A, and we're going to push nothing using this symbol. Okay. Next, going to remove some of the scribbles. Okay. Onto the fourth diagram. We are now here, Q2 to Q3. So this is the Q2, this is the Q3. Remember that Q2 and Q3 are your final state. Okay. Next, we have here, okay, connection from Q2 to Q3. We have an input symbol of C, and the stack is empty and pushing nothing. Okay. So we'll have C and nothing. Next, okay, again, that is again the step, the other transition. But then again, I was able to skip some of one of the diagram. Let us focus on the fourth symbol, this one, okay, I'm referring to. So pardon with that. So we have Q2 going to itself. Okay, going to itself allows us to have an input symbol of smaller a, okay, lowercase a, and also a capital letter A. Okay, we're going to pop that letter A. And then we have to push this symbol, which is nothing. Okay, in this case, we'll just have to write it here. Okay, so my tip for you is to look for the pattern. It always has to be the right hand side, okay, to be copied so that you can write it on top of the lines. Okay, and this is the last one that I haven't mentioned. Okay, so let's have it on this uh, diagram. So we have Q3 to itself. Okay, our input now is a C having nothing to be on our stock and nothing to be inserted. So again, we'll just have to rewrite it, push it here, write it here on top of the lines. Okay, so there you have it. That's it for today's meeting. Okay, I hope you were able to follow through. The next time we're going to meet, we're going to have uh the example number 3 input string for tracing. Okay, thank you very much. I'll see you again on our next meeting. Goodbye.